Hey YouTube, welcome back. Is your database groaning under the weight of ever increasing data, or queries taking longer and longer and longer? When vertical scaling hits its limits, there is a powerful technique to conquer this data deluge. It's called sharding, and it's all about divide and conquer for your database. Okay, I said a lot of pretty big words, but what is exactly sharding? Let's take open. So, sharding, also known as database partition, is a horizontal scaling technique of trying to make one giant database server even bigger, which is vertical scaling. If you remember the vertical scaling episode, we did talk that when we have a database server, we just add more resources to it. So we increase it. But there is a physical limit for that. And sharding, instead of doing that, instead of just like increase the server that we already have, sharding takes your massive data and breaks it into smaller, more manageable chunks called shards. How this will be. So if we have one server, instead of upgrading it, we will add more servers, and we will split the data into with these server. Think of each shard as an independent database containing only a subset of your data, of your total data. By distributing the workload across these multiple smaller databases, you can significantly improve scalability and performance, especially when dealing with truly enormous datasets. Also, you eliminated the single point of failure, because when database goes down, the other one, we have other two, can serve. And also, let's say the queries will be way more faster, because let's say that we have three databases. If like we have one query to that one database, let's say that this is S1 or DB1. So when we try to make a query to the database, it will only try to search across these data. It will not search across this data or this data. So we'll make the queries quite much faster. So we eliminate a single point of failure. We have a huge amount of scalability in with our technique in sharding. Yeah, it has a lot of benefits. We need to talk about the key to sharding, which is the shard key. The crucial element in sharding is to decide how to break down your data. This is determined by what's called the shard key. The shard key is one or more columns in your database that you use to decide which shard a particular piece of data will resides on. Choosing the right shard key is critical for effective sharding, as it impacts data distribution, query efficiency, and complexity of your system. Next, we want to talk about the not the different. Okay, I mistyped that. Because I like to make nice. Okay, so let's talk about the different strategies for dividing your data. First, we have range-based sharding. Basically, I would say data is partitioned here based on a range of values in your shard key. For example, if your shard keys are, for example, like user ID, and basically, if to user ID, you might assign users with IDs 1 to 1 million on one shard, and other users from 1 million to 2 millions to the other shards, and from 2 million to 3 millions to other shards, and so on and so forth. While simple to implement, this can lead to uneven distribution of certain ranges, because we have certain ranges that are more active than others. Next, we have hash-based sharding. This strategy applies a hash functions hash function to your shard key to determine which shard a particular piece of data belongs to. For example, you might take the user ID, apply a mathematical hash function, and then use the remainder after dividing by the total number of shards to decide which shard and which shard the data goes to. This generally provides a more even distribution of data, but makes range-based queries across multiple shards more complex. Next, we have geographical sharding. If your application has a global user base, you might shard your data based on the geographical location of your users. For instance, users in North America might be stored in one shard, while European users are on another shard. This can improve latency for local users by keeping their data closer to them. Lastly, we have directly based sharding. This approach uses a separate lookup service or a meta store or metadata store that acts as a directory. When a query comes in, the system first consults this directly to determine which shard contains the request data and then routes the query accordingly. This offers the most flexible in how you distribute your data, but introduces another component that needs to be highly available to avoid a single point of failure. Okay, when to consider sharding? There is 4 reasons, as you can see here, but I would say when to consider sharding, it's pretty big question. It doesn't have only 4 reasons, to have even more than that, but we were talking right now on high level, so we will say this famous 4 reasons. The first thing, when you outgrowing vertical scaling, sharding becomes essential when your database has reached the limits of what a single server can handle, and further vertical scaling is no longer feasible for cost effective. Next, when you have a slow queries on large tables, if queries on your large tables are becoming excessively slow due to the sheer volume of data, sharding can break down those tables into smaller, more manageable sizes, improving query performance. Next, in high write traffic, if your application experiences a very high write traffic that a single database server can't handle effectively or efficiently, sharding can distribute the write loads across multiple servers. Lastly, we have logical data separation. If different segments of your users or data can be logically separated, like by region or content, sharding along these lines can make management and isolation quite easy. Okay, next we want to talk about the complexities and cost of sharding. The first thing we want to talk about managing multiple databases. I would say you now have to manage multiple independent database instances, which increases operational overhead, including backups, monitoring, and maintenance. And also, you have to manage the consistency between them. It's really way more complex than just having vertical scaling. Next, we have across shard queries, like queries that need to access data from multiple shards become much more challenging. You might need to perform multiple queries and then combine the results in your application, which can be less efficient and more complex to implement. Next, we have the resharding. If your data distribution becomes uneven over time, or if you need to add or remove shards, the process of resharding, redistributing your data without downtime, is a complex and potentially disruptive operation. Lastly, we have increased operational cost. Running and maintaining multiple database servers naturally leads to higher infrastructure costs in terms of hardware, software license, and cloud service fees, sorry. Okay, so sharding is a powerful technique that allows your database to scale almost infinitely by distributing your data and workload across multiple servers. However, it's a complex undertaking that should only be considered when it's necessary. I would say it's a quite important technique, and it's quite important concept that you have to learn. for any engineer who wants to be succeeded in any system design interview. So, have you ever dealt with database sharding before? What were your biggest challenges or success? Share your experience in the comment section below. If you found this video helpful, please like, subscribe, and hit the notification bell so you never see you guys in future problems.